Now let's try example 2 from Unit 7, Lesson D. We are going to find the surface area of this cylinder shown right here. Now, the first thing we want to do is draw a net. So keep in mind, we talked about a cylinder has two circles on the side, and this curved part, this lateral edge, is a rectangle. So I'm going to take a coin, and this is going to be about the size of this circle, and it kind of looks like an oval because of how we have to draw it three-dimensionally, but I'm going to take this here. So if I were to cut that cylinder up and lay it out flat, then I would have a circle on each side. So that's why I'm drawing two circles with my gold dollar. And then, so these are the two circles here. And then I need to draw, oops, sorry about that, a rectangle in between. So I'm actually going to use this envelope because I couldn't find a ruler fast enough. And we're going to draw this rectangle, connecting the two circles. So if you need to do this while I am, you might need to pause it and go grab a straight edge or something, a bookmark, your student ID card, your library card, anything that has a straight edge so that you can construct the net. So if you cut this cylinder apart, you're going to have two circles on the end, and this middle lateral edge is a rectangle. And I know that my radius is 15 because that's what it says here, and the width of my rectangle is 58. Alright, so we drew the net. So it says draw the net, which we did. We're going to label each 2D shape, so we know 15 and 58, and let's find the surface area. So we have to find the area of both circles, they're the same, and the area of this rectangle. Okay, so here's what we need to do first. Let's start with this circle. Let's just start with one of them, this one right here. So the area of the circle is pi r squared. So I'm going to replace the r with a 15. So area is pi times 15 squared, and 15 squared is 225. Now, keep in mind, that's for only one circle. I have two, and they're the same size. So this is for one circle. I'm going to multiply it by 2 to get two circles. So 225 times 2, both circles together, is 450 pi meters squared. Okay, so this is for both circles. Now, if you're still writing to catch up, you can pause at any time, rewind if you need to, if you missed something. But pi r squared, this was one circle, so I multiplied it by 2 because I have two circles. Now the last part, which is the rectangle, is a little tricky. Yeah, finding the area of a rectangle is easy, it's just length and width, but we only know the width. We have to do an extra calculation. So we already know the width, that's the easy part, that's going to be 58, but I need to find the length. The length of this rectangle is the same as the circumference of the circle. Okay, so this right here we can do as pi times diameter. Now, the radius is 15, so the diameter is 30. So this length is 30 pi. Okay, so that's the length. This is the width. So length is 30 pi. So the area of the rectangle is 38 pi, or excuse me, not 38. Sorry, I meant 30. 30 pi. Now I know that's kind of an awkward step to write because we're not used to writing pi in our answer, but 30 pi times 58. So the area of the rectangle, we can go ahead and do the 30 times, the 58, and the rectangle is 1,740 pi meters squared. So we found the area of both circles, we just found the area of the rectangle, and we're going to add these. So the total surface area will be this plus this, so 2,190. Let me scoot my paper up a little bit. So 2,190 meters squared. Oops, pi. I forgot my pi symbol. So I added these two, and our exact surface area, see if I can get all this on here, is 2,190 pi meters squared. And to change it to the estimated, we're going to take 2,190 times pi, and it says measure to the nearest hundredth. So this is an 8, but there's a 7 next to it, so this is going to round up to a 9. So we get 6,880.09 meters squared. So a quick review. We took the cylinder, we cut it apart and laid it flat, so 2 circles and a rectangle. We found the area of both circles. Then to find the area of the rectangle, we had to find the length of the rectangle, which is the outside of the circle, times the width. This was our rectangle. We added the two together in terms of pi, and then we calculated it using the pi button.